Hey there, this is Mark Dumas. Welcome back to the Laboratory of Irreproducible Results. This is episode 5, and we're going to be doing a major expansion to our kinetic electronic sculpture. In the previous episodes, as you've probably been watching, we've been building a sculpture using these 16 pixel tiles. So it's a 3D printed platform with 16 motors and a controller on the back, and then these little mechanical pixels made out of bicycle chain on the front. So far, we've built up a sculpture that uses 4 of those tiles. This is a 2x2 array. They're all hooked together and working in tandem. And what I've discovered, now that we've got it working pretty reliably, is that in order to do any interesting image display, it needs to be a lot larger. So we're going to turn that 4 modular tile sculpture into a 9 tile sculpture. So instead of 2x2, it'll be 3x3. So we're going to need 5 more of those tiles. I've been busy procuring parts and putting them together. So here's 2 more tiles. There's another 2 here. And we're going to need 1 more, which I still have in parts on the table here, that I'm going to put together in a time-lapse video. This is the 3D printed platform, 16 servos, the controller. These are the little clips for holding the bicycle chain in place. Here's the bicycle chain links ready to go and some screws. So we're going to do a time-lapse of putting those together into the final tile. I know I did this back in episode 1, but I felt like it was worth doing again because there have been some design changes. And in that time-lapse video, I didn't really cover the entire process of putting the mechanical pixels in place. So I wanted to get an idea of how long that'll take. And then I'll do a time-lapse video of me putting those 5 tiles onto the sculpture and turning it into kind of one big new sculpture and testing that out. So enjoy. So the first thing I'm doing here is removing the 3D printed support structures. These are temporary structures that support these horizontal surfaces that aren't directly printed on the build plate. And now I'm using an X-Acto knife to cut away some of the brim and what's called elephant footing. The first layer to print on the build plate actually extrudes out a little bit too far. And so in order for these tiles to fit together, I've found I have to trim that up a little bit. There's probably a design change I can make in the future to prevent that work from being done. So I might save a few minutes here. Okay, let's clean all that up. Next, we're going to plug in the 16 servos. This goes really quick, but what you don't see here is that I ended up breaking several of the tabs that hold the servos in place. Now, I found from experience that you don't need both tabs to hold the servos in place, so I went ahead and finished the build this way, but it does indicate that there was some sort of problem with the print of this particular tile. I did change to a different reel of PLA material, so there may be something wrong there, I don't know. Now I'm plugging in all of the servo wires into the controller card, and you'll notice I'm having a little trouble keeping the PCB in place because the little tabs that hold it in place have also snapped off because of this faulty plastic build. And now I am dressing up the wires, trying to get that looking a little bit more tidy. And next I'm going to hook up the Arduino test program just briefly to do 2 things. First of all, make sure that all the servos are working. It's a lot easier to replace them at this stage than later. And to make sure that all the servos are in their center position, because the next step here is for the little clips to be screwed on, and I want those to be all arranged in the right direction. This is the process that I was trying to avoid, lots of little screws, but with this type of servo, it's really the only option I could find that was reliable enough. Now, you'll notice the timer in the upper left-hand corner, currently at about 24 minutes. Full disclosure here, I was not able to capture the entire build process because my camera ran out of memory. So the total build process ended up being about 35 minutes. And with all the clips on and in place here, I'll actually get through the first couple of chain installations, but you'll get the idea here. Again, 35 minutes was where this total build ended up. All right, now sort of a stop action video of me putting together these 5 newly built modules onto the existing sculpture. Sorry about the head being in the way there, but I had to kind of get some odd angles around the sculpture. So here I am kind of snapping them into place. This was actually a little tougher than I had envisioned. We'll talk about that in a future episode, but we finally got there. And now I'm connecting up the printed circuit boards on each of the tiles to one another using some ribbon cables. This part goes really quick. And now I'm hooking up the power pins on each of those printed circuit boards to the power supply. I've made a couple of more wiring harnesses here. There's a total of 3, one for each row. They simply slip on using a DuPont connector, and now I'm flipping it over to replace the chain segments that came off as I was manhandling it in the previous steps. This took a little longer than I expected, but kind of points out some of the limitations of the current design for making extra large sculptures. Again, we'll cover that in a future episode, but we finally got there. So, woohoo! Here's the front side view of our newly enlarged mechanical pixel sculptures. We now have 9 of our modular tiles, each with 16 pixels, all connected together physically and electrically for a total of 144 pixels, all controlled through this one Arduino and serial bus. Before we fire it up, I do want to cover one thing that wasn't covered very well in the previous time-lapse video, and that has to do with the configuration of the printed circuit board that manages the 16 servos on each one of these tiles. Probably remember from previous episodes, you know, the 16 servos plug into all these pins down here, power to the servos is there, and then all these pins on the left and the right, which are electrically connected to one another, is how the power and serial bus gets propagated from one tile to the next. Now, in order for the Arduino to be able to resolve what it sees as multiple printed circuit boards for the servos on that same bus, each one of these things has to be configured to a separate address, and you do that through these 6 pairs of solder pads on the circuit board. So as shipped like this, this one would respond to the software as hex 40, and the next one in line I had to go bridge the solder between these 2 pads to make it respond as hex 41 and so forth. And that's how the Arduino can tell the difference between all of these devices that are on the same bus. Anyway, just wanted to make sure that that was clear. And let's see, let's fire this thing up. I think we need to re-aim here. So I'm going to plug in this new 60 amp power supply. I think we're using maybe half of its capacity. And then we're going to plug in the Arduino to some power. And should start right up. So nothing fancy here. All I've done is extend the diagnostic that we have seen on the previous versions of the sculpture. It starts off here with a little bit of wave action, just so you can see that everything is moving and in the right order. And in a second here, it'll break into the random motion subroutine, and then it'll kind of go back and forth between those two. So from the point that we finished the time-lapse video of putting this together to here, it was a pretty quick debug. Basically in the software, all I had to do is extend some array sizes and chase out a couple of bugs there. And once I had that done, I actually found one more hardware bug. One of the tiles I had inadvertently plugged the servos into the circuit board in slightly wrong order. So they were, no harm done, nothing burned out, but they weren't in the right, they weren't moving in the right sequence. So got that straightened out really quick. So what's next? Clearly we've got a lot more pixels and real estate here to play with, and the next episode I'm going to be doing, going back to the more artistic work on the sculpture and trying to figure out how to make it interactive and maybe show some image data. And I think that it's going to be pretty nice just like it is, even if we're not going to be able to extend this particular design that much further. So what I'd like to do is invite you to leave any comments on the YouTube comment section. If you've got any questions about how the thing is working, how it's designed, or if you've got any suggestions on how to make things better, or ways to display some interesting patterns and images, I'd love to hear from you. And then until next time, keep on making.